Alrighty, in this video, we'll be covering reducing rational equations when dividing by another rational equation, or not reducing, but simplifying. So, a rational equation is, in the most basic form, 1 over x. So that's what a rational equation is. So, when reducing it, we'll start off with just reducing a normal one before we go into dividing. So, reducing means to have it in its simplest form. So if we have, let's say, 3 over 3x plus 6, what you can do is find the highest common multiple of every single thing in here. So with this bottom equation right here, that would be a 3. 3x is 3, and plus 6, if you take a 3 out, you get 2. And then x and 2 have nothing else in common besides a 1, which you can't really take out. So what we are left with would be 3 over 3 times x plus 2. Now, since we have a 3 on the denominator and the 3 in the what's the top called? Numerator, then we can just cancel those two out and they both become 1. So 1, 1. So then we're left with 1 over 1 times x plus 2, which is just x plus 2. So there we go. We've simplified 3x over 3x plus 6 down to 1 over x plus 2. And if we want, we can even pull up Desmos, which, hold on, fix the window. Go like that. And go down. So there we go. And we can even go into Desmos and go 3 over 3x plus 6. You get that graph, and you go with 1 over x plus 2, and boom, they match up. See, blue, red, they match up. So that means pretty solid right on. So we'll get rid of this and we'll go on to a more complicated problem. But first, if you remember, probably from, 5th or 6th grade, when you divide a fraction, why am I in white? That's a little weird color. There we go. When you divide a fraction by another fraction, so we'll say 1/2 divided by 3/2, then what you end up having to do is separate the two sections, top and bottom, and take the bottom, bring it up, bring it up, and flip it so the top becomes the bottom, the bottom becomes the top, otherwise known as, I like to call it flip and multiply. So what you do is now you have 1/2 times 2 over 3, which then you get, and then you just multiply across like that. So 1 times 2 is 2 over 6, and then you can reduce that a little further. 2/6 is the same as 1/3. So 1/2 divided by 3/2 is 1/3. So that's the same concept that we're going to be working with when we're dealing with rational equations. So let's start off with something simple like 1 over x divided by, I don't know what sounds good. We'll do 3 over 2x. So what we do, separate, drag up, and flip it, and then multiply. So we're left with 1 over x times 2x over 3. Because remember, here we flip the 2, and then we multiply. So what we're left with is 1 times 2x, which is 2x, over 3 times x, which is 3x, over 3x. Now, if you notice, we have an x on the top and the bottom. That means we can simplify by canceling those 2 out and replacing with a 1. 1 and 1. And then 2 times 1 and 3 times 1 is just 2 and 3. So left with 2 over 3. So that's pretty simple. 1 over x divided by 3 over 2x is the same as 2/3. Pretty simple. Alrighty. Now on to a more difficult one. We'll do 3x plus 1 over no. We'll start off with something a little simpler and then get into that later video. So we'll do 4 over 2x plus 3 divided by 3 over 4x plus 7. That sounds some strange numbers, so we'll work with those. So we'll separate top and bottom like that. Then we flip the 2 on the bottom. Bring our new one up. So we've got 4 over 2x plus 3 times 4x plus 7 over 3. And then we multiply across. Don't forget to distribute. So we've got 16x plus 28. 16x plus 28. Because we distribute this 4 across both of these. So 4 times 4x is 16x, and then 4 times 7 is 28. And then we do the same thing with the bottom. 2x plus 3 times 3. Would be 6x plus 9. Now comes the part where we see if we can divide either of these any further, which I don't believe so, but let's check and just make sure. So with this top one, the most we could take out would be a 4, and then we'd be left with our original of 4x plus 7, and then the bottom, the most we could take out would be a 3, and we'd be left with our 2x plus 3. So, and then if we try and take a 2 out of the top, we can take a 2 out of the top and we'd be left with 8x plus 14, but we couldn't take a 2 out of the bottom. Take a 4 out of the top, can. Alright, well, then I think that is the simplest we can get this equation, because if you notice, we cannot take out an x because there is not an x on either of these terms here. So that is the simplest our equation can get down to. Now, if that makes sense, then we're going to jump straight into a much more difficult one of, we'll say, 4x plus 1 over 5x plus 2. Now this in itself is still a rational equation. It just has an x on the top and an x on the bottom, which is perfectly normal. And then we'll say that over 20x plus 13 over, I don't know, like 4x plus 3 So remember, don't get scared because there's an x in all four. Doesn't matter. Separate. Flip. Bring it up. 4x plus 1 over, that's not a 2. Ooh. 5x plus 2 times 4x plus 3 over 20x plus 13. So now what we do is multiply so multiplying the top, we get 4x times 4x is 16x squared plus, or 1 times 4x is plus 4x, and then 4x times 3 is plus 12x, and then 1 times 3 is 3, so plus 3. Then you get 16x squared plus 16. That's a horrible plus sign. Plus 16x plus 3 over our bottom one, which would be 5 times 20x, so 100x squared, and then times the back, which is 3. So, oh no, 13. That's 13. So 5 times 13 is 65. So plus 65x. And then multiply the 2 by the 20 plus 40x. And then the 2 by the 13 plus 26. So then, after all this, we are left with 16x plus 16, or 16x squared plus 16x plus 3 over 100x squared plus 85x plus 26. Boom. Those are two quadratics just on top of each other. And if we go to our trusty, love this website, Math Papa? Yeah, Math Papa. And then, whatever. Math Papa. I'll try to calculate. There we go. Now, if we plug in our equation of 16x plus 16, 16x squared plus 16x plus 3, all over 100x squared plus 85x plus 26. Calculate. See, look at that. Simplified already. So this is as simple as it can get. But yeah. If you can just remember the 5th or 6th grade rules for dividing by fractions, then you're going to be able to nail this stuff. It's not much different. Don't get scared by the x. It's just there. Just think of it as a number. And then, again, don't get scared if you start seeing quadratics. Quadratics are normal. Sometimes they'll probably even cancel each other out or something, or you'll be able to take like a number out and reduce them. But just in this case, since I was making these up on the spot, these obviously did not reduce. But yeah, anyway, thanks for stopping by. Happy studying, and goodbye.